This is Accelerated Geometry 5.7. We're going to learn about two new things in geometry today. One is called a midsegment of a triangle, and the other is called the midsegment of a trapezoid. And then we're going to learn a conjecture about each. So here is the midsegment of a triangle. It is a segment, connects the midpoints of two sides of a triangle. So here is the midpoint of this left side, shown by the tick marks, with two tick marks on each, so that's a midpoint. And on the right-hand side, this is the midpoint of the right-hand side of that triangle. When you connect those across, that is a midsegment of a triangle. Now, here's a midsegment of a triangle. So this is designed so that this is a midpoint of side AB, and this is a midpoint of side BC. When I connect them, I get this midsegment. Okay, if I look at the midsegment, its slope is 0.14, and if I look at the midsegment of the third side in this triangle, the opposite side from where it is, this is the first side and second side, those are used to get the midpoints, to get the midsegment. So those are the first and second side. The third side would be this side over here. If I look at its slope, it is also 0.14. So it seems in the midsegment of a triangle is parallel to that third side of the triangle. Okay, so I'm going to move those away, and then I'm going to bring the measurements of the midsegment and that third side. So 8.10, half of that, 4.05. If I move this, 4.20 and 8.40. So it seems that the midsegment of a triangle is always also half of the third side. So we're going to combine those into conjecture number 51 on your conjecture list. The midsegment of a triangle is parallel to the third side and half the length of the third side. Next, we're going to talk about the midsegment of a trapezoid. It is a segment, just like the midsegment of a triangle is a segment. It also connects midpoints, just like the midsegment of a triangle connects midpoints, but it connects the midpoints of the two non-parallel sides. So not the parallel sides, the non-parallel sides. So in this picture, this is a non-parallel side on the left. This is a non-parallel side on the right, and you can see that these points are midpoints, and they're connected, and so that is the midsegment of a trapezoid. So the midsegment of a trapezoid has some special qualities also. If I look on the right-hand side here, the slope of the top base, the slope of the bottom base are both 0.33, and the slope of the midsegment is exactly the same. If I move this, see how those three slopes still stay exactly the same. So the first part of this conjecture is the midsegment of a trapezoid is parallel to the bases. Then we measured the top base, the midsegment, and the bottom base. And then I took these two bases over here, and I found their average. I added them up and divided it by 2, and look what I got, 4.26. So if I get rid of those and highlight this, 4.26 was the midsegment's length. Okay, if I move this, look, 4.90, and this is the average of the bases, the top base plus the bottom base divided by 2. So the midsegment conjecture for a trapezoid says the midsegment of a trapezoid is parallel to the bases and is equal in length to the average of the lengths of the two bases. So that is conjecture number 52. These conjectures are also written out in your class notes on the last page. So here is conjecture 51, and there is conjecture 52. Be sure that when you add these onto your conjecture list, that you also do a meaningful sketch next to each one so that you can study from it and know what it is saying.